Day 6 of slot 2 questions. The number of positive integers less than 50 having exactly two distinct factors other than the number itself. So the number is x now. 1 and x definitely are going to be the factors, and it's going to have two distinct factors again, which means the number is going to have four distinct factors. Any number which has four distinct factors, my dear, that is either going to be in the format p cube, a prime number raised to the power 3, correct? So this will have 3 plus 1, 4 factors. So how many numbers less than 50? How many cubes less than 50 do you have? 1 cube is there, but 1 will not have 4 factors, right? So 2 cube is possible, which is 8. Then you also have 3 cube 27, that's also possible, okay? And then 4 cube 64 is not possible. So numbers in this particular format are going to be 2 solutions. Now there can also be numbers which exist in the format of the product of two prime numbers, okay, raised to the power 1. Then 1 plus 1 2 into, again here also 2, you'll get 4 factors. So product of two prime numbers. So let's start with the smallest, my dear, 2. So 2 into 3, and they have to be distinct prime numbers. 2 into 3 is less than 50. 2 into 5 is also less than 50. 2 into 7 is less than 50. 2 into 11 is less than 50, yeah, 2 into 13, and then you have 2 into 17, yes, 2 into 19 is also less than 50, 2 into 23 is also less. Okay, so you can't go further than this. And similarly, you started with 2's now. If I start with 3, like 3 into 2 is already, then number 6 is already counted, okay. So 3 into 5 is also possible, it's less than 50. 3 into 7 is also possible. 3 into 11, 33 is also possible. Then 3 into 13, which is going to be 39, this is also possible, okay. Then the moment I take 3 into 17, there will be 51, which is not possible, okay. Now let's check out for 5. 5 into 2 is counted here, 5 into 3 is also counted here. So 5 into 7 is possible, 35. Now if I take 5 into 11 next, 55 is going to be greater than 50, that will not satisfy. So let's count the number of solutions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 here and 2 here. Okay, you will have 15 such numbers.